Welcome to my IB Computer Science HL internal assessment. As you can see, there are two modes. The solo mode is the classic Minesweeper game that we all know and love, and dual mode is a suggestion for improvements where at one point you'll be able to play against someone else at the same time and try to race them to see who can finish the puzzle first. But for now, we just have solo mode. You can control the cursor or the red boxed icon with easy WASD keys on your keyboard, and um, you can then check a specific square with the space button, and it'll pop up the whatever you checked, like a number, a bomb, a flag, or a blank space. When you check a blank space, many spaces will open up to reveal uh, all of the spaces connected to the blank space, just like the classic game. Um, you can plant and unplant flags with the F key easily. You can plant as many as you would like, and then you can unplant them by doing the same thing, going over and pressing F. Um, when you plant and unplant F, you can see the number of flags tick up and down to represent how many bombs are left. The puzzle can be uh, clicked on like that. When you hit a zero, a large area will open up just like the classic game. And I'm going to show you two different ways. I'm going to show you what happens when you lose and what happens when you win. What happens when you lose is you should be able to see what you did incorrect. So when you click on a bomb, the timer stops. The entire screen is revealed, and anything that you had a flag on, the background becomes red, so you know which ones you incorrectly clicked on, such as these ones that should not have had flags on, and over here. And the bomb that you incorrectly clicked is red, so you can see that also. Um, I am now going to attempt to win a round to show you the end screen, which will have the timer score at the end, and I will explain to you the program while I do that. So my program is made up of 5 main classes and 2 types of utility classes. The first main class that it uses is the control class, which takes care of the WASD, F, and space keys to be able to, as the player inputs, so that the computer knows how to react to what the player wants to do. The second main class that the program uses is what I call the Minesweeper game class, which is an object-oriented class where all of the data that is used in the instance of the game is connected to the single object of the game, so that each game is separate and different and can be replayed over and over. The third main class in the program I call the Launch Minesweeper class, which creates a Minesweeper game object and runs the program, creating a few tables and methods for the program, but that's the main use of it. The fourth main class I call the create board class, which is very important for the beginning and creation of the game. It initially randomly selects 34 coordinates and makes sure none of them repeats for where the bombs will be placed. Then it goes through what I called a game table, which is just a two-dimensional array, uh, and places the bombs on the coordinates. And the bombs were a 9 as a number, and that represented a bomb in terms of a numerical value. And then it goes through the create board class goes through that game table and populates the table with numbers. So if there's one, it goes to each and every box in the two-dimensional array and looks all around it, all 8 pieces around it, and sees if there's a bomb. If there's a bomb, it ticks up, and it goes from 0 all the way to 8. 8 is extremely unlikely. The most common is, like, highest is 5. It's very unlikely to see a 6. But it'll tick up, and then the entire game board will be filled with either zeros or 1 through 8 for numbers to represent how many bombs are around it, and a 9 for a bomb. And you can imagine this game table as basically the answer key for the game. It shows all of the values of the game overall. Um, and then it also creates what I call the display board or the display table, which is the board that records what coordinates the player has already checked or placed a flag on. A flag, I chose randomly the number 20 to represent the flag. So if a 20 was placed on the display board, the game knew that it can't be checked and that there might most likely is a bomb there. And so the next main class and the final main class uses this display table a lot, which is the paint class, which is a Java class that imports JPanels and JFrames to create the visual effect of the game. And the paint class displays the display board and prints out the values on a JPanel and is repainted accordingly every single time. Say the player hits a WASD key, it repaints the different cursor on a different place, the little red box. Or every time the flag is placed, it repaints. And this will repaint, of course, the number of flags on the top left corner and the time so far on the top right. Anyway, and then the last two types of classes would be the utility classes I'm calling, which would be the J component class, which you have to make one of these for each of the numbers, so 1 through 8, and a bomb and a flag, which basically allows the program to paint out or print out on uh, the user interface, the player's game board, basically, what the pictures that it uses. So it allows you to print an actual flag onto it instead of, say, printing an F or a 20, so that's more user friendly and actual a game instead of a rudimentary program. And so you have to make, there are multiple classes. There are, I think, 11 J component classes. And then the last utility class is a time runner class, which is a simple class that is used in Java to count time, and it just ticks up every second and counts the time according to when the game starts, and then it'll stop at the end of the game, and the uh, winning table shows it very easily. Um, and thank you for watching my Sci IA presentation. Thank you very much.